angles of polygons, and we're going to be looking at pages 7 through 9, and we're going to answer the question, what is the measure? So question number 21 starts with your team, determine the sum of the measures of the interior angles of the Pentagon using any method. You may want to use the fact that the sum of the interior angles of a triangle is 180 degrees. Be prepared to share your team's methods with the class, okay? So if we know that a triangle has interior angles of 180 degrees, we can take this pentagon, because a pentagon has 1, 2, 3, 4, 5 sides, and we can see how many triangles are inside of that pentagon, okay? So we're going to pick a vertex. I like this one up top, but you can pick a different one. You're going to start with just one vertex, put a star by it. The one that you put a star by, you're going to see how many other vertices you can connect to and make triangles inside of that pentagon. If you try to connect to that one, it's just going to be a side. So go to the next one, draw in your diagonal, and that gives you your first triangle. Then go to the next vertex, draw in your diagonal. That's going to give you a second triangle and a third triangle. Each of these triangles has 180 degrees in it. This triangle has 180 degrees. This triangle has 180 degrees. This triangle has 180 degrees. So we could add up 183 times, or we can take 3 times 180 on our calculator, punch it in, and that's going to tell us that this triangle, or that this pentagon, has 540 degrees. Okay? Any questions on question 21? All right, question 22 says, sum of the interior angles of a polygon. In the previous problem, you found the sum of the angle of a pentagon. But what about other polygons? Part A, determine the sum of the interior angles of the other polygons using any method. Complete the table for the polygons with up to 8 sides. You may divide up the polygons among your team members, but make sure to check each other's results. Okay, so the first one they start with has 3 sides, obviously. It's a triangle. A triangle has 180 degrees. So if you multiply 1 times 180, you get 180. That's kind of obvious one, okay? For the second figure, it has 1, 2, 3, 4 sides. What is a 4-sided polygon called? Anybody know what a polygon with 4 sides is called? Starts with a Q. Quadrilateral, right? So you're going to pick any vertex. I picked this one right here. Can't draw a diagonal to here, can't draw a diagonal to here, but you can draw one there. That creates 1, 2 triangles. And 2 times 180 is 360. The next figure has 1, 2, 3, 4, 5. Just like the one we just did in the problem up above, so it's a pentagon. Pentagons, when divided up from one vertex, you pick one to start with, draw in as many diagonals as you can. That should create 3 triangles. 3 times 180, like we learned up here, was 540. So this is the same as the one we just did up top. Okay? The next polygon has 1, 2, 3, 4, 5, 6 sides. What is a 6-sided polygon called? Who said it? Hexagon, right? So a hexagon has 6 sides. We pick one vertex to start with, and then you draw in as many diagonals as you can. So here you got 1, 2, 3, 4 triangles. You multiply that times 180. That means the sum of the interior angles is 720 degrees. Okay? The next one has 1, 2, 3, 4, 5, 6, 7 sides. Does anybody know a 7-sided polygon? That's kind of a tricky one. No? Hepta. It's a heptagon. You can always Google that. If you don't know what a polygon is, you just type in, what is a 7-sided polygon? And it'll spit out the answer for you. Okay? Draw in as many diagonals as you can. That gives you 1, 2, 3, 4, 5 triangles. And each triangle has 180 degrees. So 5 times 180 is 900. That means that the sum of the interior angles of a heptagon is 900 degrees. And the last one has 8 sides. Telling you down here, 8 sides. Pick a vertex to start from. Draw in as many diagonals as you can. That creates 1, 2, 3, 4, 5, 6 triangles. Each of those 6 triangles has 180 degrees. So you multiply 6 times 180, which gets you 1,080 degrees as the total sum of the interior angles of a polygon. That will be, what would an 8-sided polygon be called? Octagon. Like an octopus has 8 arms, so an 8-sided polygon is going to be an octagon. All right, then they want you to fill in this little chart using the exact same numbers you just got here, right? So 3-sided is 180, 4-sided is 360, 5-sided is 540, 6-sided is 720, and so forth. The 100. If we go all the way up to 8, we should notice a pattern, right? If this has 3 sides and we multiply 1 times 180, this has 4 sides, we multiply 2 times 180. This has 5 sides, we multiply 3 times 180. So what are we doing every time? So if this has 6 sides, how do we get to 4 here? And this one is 7 sides, but how do we get to 5? There's a pattern here. What is the pattern? What did you say? Subtract 2, yes. Subtract 2. Each time, we're going to subtract 2. So the formula, or what we call for any n-sided polygon, any number-sided polygon, you're going to subtract 2. So n minus 2 times 180. And so if we were to do 100, we would take 98 and multiply it times 180 degrees. That would give us the 17,640. So that's what we show in part B. It says, what is the sum of the interior angles of a 100-sided polygon? Add the sum to your table and explain your reasoning. You're going to take the number of sides minus 2 and multiply it by 180. You can check it on your calculator. You should get 17,640 degrees. And then part C just asks you for the formula. An N-Gon is a polygon with n number sides. So I could give you a random number like a 65-sided polygon. Okay? 65, what would you do with 65? Subtract the 2 to get to 63 and then multiply by 180. All right? Anybody still writing? Okay. Let me give you a second to catch up. 23 says, Fern is helping a friend with her math homework, and they get stuck determining the value of x in the diagram shown at right. Fern says, I know how to calculate the sum of the angles of a hexagon, but how am I supposed to determine the individual angle measures? Jeremy says, well, this one is easy because all the angles are the same. You can just divide. What does Jeremy mean? Use your findings from problem 22 and the diagram to write an equation solving for x. Okay? So if this polygon has 1, 2, 3, 4, 5, 6, 7. Oh, that one has 6. Oh, yeah. Did I write down the wrong number? Okay. That should be a 6 right there. Sorry. So 6 minus 2 times 180. I just wrote the wrong number. 6 minus 2 times 180 should be 720. That's how many total degrees in that hexagon. But then to find just one of them, we're going to divide by how many sides it has. So we're going to divide by 6. So if you take 720 on your calculator, divide it by 6, you're going to get 120 degrees. Okay? Part B, Fern says, I get it. Hey, that could work for other regular polygons. Determine the measure of each interior angle of a regular octagon. Okay? So octagon has 8 sides. So we're going to start with our 8, subtract the 2 to get 180 for 1,080 degrees total. So that would be all of the angles inside. If we want just one, we're going to divide by the number of sides, which is 8, because it's an octagon. That would give us 135 each. So this one would be 135, this one would be 135, this one would be 135, this one would be, you want me to say it 8 times? Yeah. Okay. Part C says, what about the interior angles of other polygons? What are the measures of the angles of a regular Nonagon, which is 9 sides, and a 100-sided polygon? So let's do the 9 first. So we're going to take 9 minus 2, which is 7. 7 times 180, and then divide it by 9 to get each angle of 140. You can do this on your calculator all in one transaction. Can you see it? Yes. Okay. So in our head we can go, okay, 9 minus 2 is 7. So 7 times 180, hit the equal sign, and then hit divided by 9. It's going to take that previous answer of 1260 and get you 140 degrees. Okay? Same thing with 100-sided polygon. So 100 minus 2, you should be able to do that one in your head, is 98 times 180. Then we're going to divide it by 100, and we get 176.4. Okay? Any questions on part C? Okay. Part D, now they just want us to write it with a variable, okay? So will the process you found work for any regular polygon? Write an expression that will calculate the measure of an interior angle of a regular N-Gon. So yes, you're going to say yes, it works for all of them. We're always going to say n minus 2 times the 180 and then divide by the number of sides. Okay? That formula is going to work no matter what sided polygon you have. You could even plug in 500 there. Question 24. Jeremy asks, what about exterior angles? What can we learn about them? Examine the regular hexagon shown at right. Angle A is an example of an exterior angle. So exterior is going to be on the outside instead of on the inside. It is on the outside of the hexagon and formed by extending one of the hexagon sides. What can you conclude about the exterior angles of a regular polygon? Their measures are going to all be equal because they are all supplementary to the interior angles that have equal measure. So each interior angle in this case is going to be 120 degrees. Oh, because each interior angle is 120 degrees, each exterior is going to be 60 degrees. Okay? And then what is the sum of the exterior measures? It's going to be 360 because you have 6 of them at 60 degrees each. So 6 times 60 is going to give you 360.